Hello, 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 and welcome back to Super STEM for week 2. I'm so happy that you've joined me again. So, last week we dipped our toe into the water with respect to the thinking that you have to do as a scientist, doing some building and whatnot. But this week we're going to look at a certain scientific concept that's simple but pretty significant, and that is floating. Now, you may expect certain things to float while you expect other things to sink, such as if you toss a rock into the water, it's not going to float on the top, whereas an apple, that's probably going to float. But there are actually reasons why different objects float and others don't. And we're going to talk about one of those today, and that's called density. We'll get into more about what that is later on in this video. But first, I'm just going to demonstrate. So, take this rock for instance. It's tiny, but do you expect it to sink or do you expect it to float? Let's see. It sank. Even though it was really small, it sank. But what about this cork? This is much bigger than the rock. So, will that sink? No, it ended up floating. So, does size affect whether something floats or sinks? Does weight affect whether it floats or sinks? Well, this cork is much bigger than the little rock that I just threw in, and it floated. So it can't be that bigger objects are going to sink. And is weight what causes it? Well, I would dare say that this cork is heavier than the tiny little pebble that I just threw in. You see, it's actually a combination of the weight and the size of an object that affects whether it sinks or floats. And that is a concept that we refer to as density, which I will illustrate right here. Now, density is, like I said, affected by both weight or mass, which is how much stuff an object is made up of, as well as the size of the object. Now, let's take a look here. All objects are made up of tiny little particles. You may have known that, maybe you didn't. But this cork, this rock, they're all made up of little tiny particles. And how far apart those particles are varies with different objects. So in this rock, as I have illustrated here, all of these little particles are really closely, tightly packed together. Whereas in the cork, they're a bit further apart. It's a bit more airy. It's less, what we would say, less dense. And density can vary or remain the same across different objects. For example, a stone, a very large stone, may be the same density as a very small stone, whereas maybe a tiny little stone, like I just threw in the water, is much more dense than this giant cork. And that is what determines whether something will float or sink. Because as you see, as I have drawn here, water is also made up of a bunch of little particles that also are packed together to a certain degree. And in the case of the stone's particles are packed together much more tightly than the particles of the water. And so the stone just wants to sink. But on the other hand, the cork's particles are more spread apart than the water particles, so that's what causes the cork to float. It all depends on how far apart and how packed together the little particles are that make up an object. And actually, you can influence how well something floats by changing the liquid that it's floating in. For example, I don't know if you've noticed this, but when you go swimming in the ocean, you'll find that it's a lot easier to float in the ocean than in a swimming pool, for instance. And that's because the ocean is salt water, whereas the pool is just fresh water. Now, when you add salt water, you make it denser. You make the particles more tightly packed together. And that is what causes some things to float better in the ocean because, well, the difference between the density of the object that's floating and the density of the water is greater. So I don't know if you can see, but this cork is going to float a little bit better in this water because it's salty, and the difference between the density of the cork and the density of the water is more significant. The water is even more tightly packed together than this water here. But then density, all things can have density, liquids and solids. So it's not just solids that can float. Um, just take a look here. You can see 3 different liquids that are stacked up in layers. At the bottom, we have corn syrup, which kind of has the consistency and thickness of the maple syrup that you use on your breakfast. And then in the middle here, we have water, just plain water out of the tap. And at the top, we have canola oil, which is something that you often cook with. And the thing is, the syrup at the bottom is much thicker. It has a greater density than the water that's in the middle, whereas the oil is less dense than the water, so it floats on top. And because there are these differences in density between these different liquids, they're going to float on top of one another. They're not going to just mix. Now, there's another factor that causes water and oil to separate. That's more of a chemistry related thing, but we're going to talk about that later this summer. But what determines whether oil or water floats on the top is the density, and the oil is less dense. It's thinner. The particles are not as closely packed together, so it floats on top, which is pretty neat. If you actually swirl it around and stuff, it remains in position. It doesn't mix together because the thicker liquids want to stay at the bottom and the lighter liquids want to stay at the top, or the thinner liquids want to stay at the top. So it really isn't all about how heavy or light something is, because you see boats floating in the water, but then a tiny little pebble doesn't sink. Well, a tiny little pebble sinks, but the boat floats. That's what I meant to say. And that's because of density. You see, something doesn't have to be really big in order to be dense and sink. You might have giant corks or giant pieces of wood that can float because it's their density that's low enough to allow them to float. It doesn't have anything to do with weight or the size alone. And so I find that quite neat. Now, for those of you who like math, density is equal to the mass of an object, which is what we would find by maybe weighing this on a scale, divided by the volume of the object, which is how big it is. So this water, for example, fresh water always comes out to having a density of 1 gram per cubic centimeter. So that means that we take the volume, the space that this water takes up, and we divide the weight of the water by that. We would have to not include the weight of this jar, just the weight of the water. But that gives us the density. And so you can find the density of all sorts of things if you take the mass and estimate how big it is. And you can probably guess what things are going to float and what things are going to sink based on how light they are and how big they are. Really big things that are really light are probably going to float, whereas small things that are really heavy, those are probably going to sink. You can kind of gauge how dense something is based on just feel and appearance. which is kind of neat. So thank you so much for joining me for this first part of Super STEM Week 2. In the next video, we're going to be talking about another factor that affects whether things sink or float. There's density and then something else. And so we're going to talk a bit about that in the next video. So thank you and have a good day.